In this video I will talk about the R values and L values. So let's see the assignment operator. So here we can just create a variable and then assign to them the value. Yes. So we can just assign to the variable another variable like this, assigning to them the expression or the function, maybe, for example, as but we cannot do we cannot assign to the expression, for example, the variable like this. So if we just execute this kind of program, we will get something like this: lvalue required as left operand of assignment operator. If I don't mistake, assignment is. So what is lvalue? Okay, first let's see the problem. Let's try to understand it by ourselves. So here, when we assign the values, the expression to the variable or the values, so we need to just save this the result of this expression to the variable. But what you need here, so why this code will not work? Because it's not clear to the C++ what do you need here, or what you want to from C++. So for example, so where to save this variable z5. Yes, so in this case you know that not in any like expression, not in any place you can just set the expression like this, the function like this. Okay, so what is lvalue? Lvalue is which you can just set in the left side, which you can just which has the address to save. But rvalue is in short can be explain it as what you can just get, what you can just calculate, and it's like the R value. And these kind of problems will not also only in the assignment operator. It can meet, for example, in the functions like this. For example, if your function here, if your function like requires the variable and the reference, it's not the same. For example, here we can just call them like uh, this and m. Yes, we can just set here the value, the expression, the the function. So in short, it's like R value, but here you cannot set because you have the problem. So the problem was cannot be non-constant value or reference of type to an R value. So R value here it requires L value. Here it's convenient to work with this, but in this case, in the other side, for example, if you just change the variable here and the variable here, so if you just call this function with the variables, then it will not like change the n, the first variable, and it will change the m. You can just make sure like with printing these variables. So here you can just use it like this. So use this kind of functions like if you want to just change the variable, then you can just use the references here. It will change it. But if you want to just use this variable, the values of this variable, it will be like this. So in this case, you can just use here the expressions. You don't need to create the variable for the expressions. You can just like directly use it in the function. But here you cannot do it. So because it requires L value. Here it requires L value. Also, in the pointer, for example, when you create pointers, when you get the references, so let's see, you can just get the address of the uh, L value, but we cannot get address of the R value like this. It will not work. Also about the second level pointer, so this one is also the this one is fully is also like R value, not L value, because when we just use the second level like pointers, you can use the pointer, but we cannot do it like this because it's not like clear what do you want to save, where do you want to save. Okay, here it requires lvalue, so the pointer. But when you work with the pointer, when you work with the pointer, so the referencing it will be like it's the L value. It can be counted as L value because you can just change it like this. And also the indexing of the matrix is the array is also L value. For example, you can just change it like this. Not I, but also the function can just return L values like this. And but like this, in this case it will stand as L value, so we can just and so on. So it's about R value and L value.